Hey everybody, welcome to Chapter 7, Comparing Two Groups. So this is actually something that is very common that we do in higher ed research and social science research more broadly. So this is a really good, hopefully useful chapter. So when we think about comparing groups and how we often use this like pretty simple comparison, in our own work, we think about the higher ed outcomes of promise versus non-promise students, or white students versus non-white students, Pell versus students who are not low income. So this is, hopefully this is useful because this is a lot of what we do, even just very descriptively, this is what we do. So a couple of things that I thought were worth mentioning toward the beginning of the chapter is actually a little bit of like a vocabulary lesson. When we talk about variables that are binary or dichotomous, or sometimes they're called dummy variables, they are variables that take only two values. So like male, female is a dichotomous variable, promise, non-promise, Pell, non-Pell. These are dichotomous or binary variables. Now typically these variables are coded 0, 1, right? Like promise equals 1, non-promise equals 0. And in that case, you can call them a dummy variable as well. So all of those words are interchangeable. I know that there was kind of just like a vocabulary feature a little bit in the book. So I just wanted to highlight that. Those are commonly used words. They all mean the same thing. The distinction for a dummy variable is that it's 0, 1 versus like MF for male, female. That is dichotomous, but that wouldn't be considered a dummy variable. So there's your cocktail hour trivia. Also, the point about the longitudinal data versus the cross-sectional data I thought was really important. In some of the writing reflections, the first research reflection, a lot of people made a really good point about that survey, which was kind of awful, would have been so much better or more useful if it had been more longitudinal in nature, and that's a really good point. So longitudinal means over time, whereas cross-sectional is like a snapshot in time. So the example I always give when I talk about that is all of these THAC reports that we do. Very few of those tables in the various THAC reports, the fact book, the TELS report, whatever, are longitudinal in nature. It's more like a snapshot in time. Like in fall 2017, this is what things looked like, higher ed wise, whereas longitudinal is some of those more kind of waterfall looking figures, or just like a trend line over time. So I think that's probably pretty familiar to everybody, but because that came up in the text, and I mean, we can talk about independent and dependent samples and stuff like that. That kind of plays through this chapter, but I think really the point of all of that is just cross-sectional versus longitudinal is the sort of crux of what you need to be able to talk about and be fluent in. So I think the biggest piece of this chapter that is worth spending a couple minutes talking about is this idea of comparing two groups, the difference in means or difference in proportions. So there are a couple ways to do that, and the easiest one, and I realize I'm being a little facetious, the easiest way to do this is to subtract them, right? So you take one mean, you take another mean. So mean ACT score for females, mean ACT score for males, you subtract them, and you say, okay, there's a difference of 2 points, or something like that. Okay, so that's easy, right? How then do you know if that's actually a real difference, right? If that's a statistically significant difference, if that's a difference you actually need to care about. We've talked a little bit about you might have like a statistical result that doesn't actually matter like in the real world. So how do you know if that difference is actually significant? It's a significant difference between the two groups. So there are a lot of formulas laid out in the book, and I'm not going to talk through the formulas because they're all right there, though I'm happy to clarify anything if people have questions as you read through it. But basically you need to know the standard deviation of the responses. So the example that they use in the book is about housework, right? Men and women, how much housework they do. So what is the average response in terms of the number of hours doing housework as the example, and what is the standard deviation of those responses? So if you know the standard deviation and you know the mean, obviously, if you know the standard deviation, you can calculate the standard error, and that is what you need to calculate whether or not this is actually a significant difference. You can do the difference in means t-test or get a z-score depending on what you need to do for your given question. So yeah, so it's a little facetious, right? To be like, you just subtract them and you see what the difference is. But you have to be able to really say, for an example that's more relevant to us, promise students persisted at higher rates than their non-promise students, because 60% of promised students persisted compared to 40%. Well, is that 20 percentage point difference between the two groups actually statistically significant? Is there actually like a real effect there? So that's something you need to be able to say with surety. I also thought a really good little tidbit in there that you guys might have just kind of read over was this idea of the relative risk or the ratio. That's actually something that's used pretty often in like real life, as well as some more advanced stats thinking about risk ratios and relative risk and things like that. Basically, if you just divide one mean by the other, you will get the relative risk of one behavior or another, or a difference in means. So again, with this example about the housework, the mean response for women about how many hours of housework they do a week or whatever that is was 61% higher than that of men. So that is just the quick calculation related to relative risk, or the ratio, which is often used in, maybe not often, but sometimes used in like mainstream media when they talk about, voter ratios or something like that. So that's just something to be fluent in. If you ever do any work that is like logistic regression or categorical work, if you're taking further classes down the line, if you're going to do the ADD, that will come up. The risk ratios will come up for sure. So, okay. So, moving on, there is a good bit of real estate given to confidence intervals in this chapter. Read up on that. Let me know if you have questions, but I don't think we need to spend a ton of time. I didn't ask you to do any problems that calculate the confidence interval, but basically, if your answer, if your result of whatever analysis you're doing, your t-test or your z-score or whatever else, falls within the confidence interval, that 95% most often confidence interval, you can reject the null hypothesis that there is a difference between groups, or that your result is significant or whatever else. So read up on that if you want. I don't want to spend the time, like I said, talking about that, but it's basically just if it falls within that interval, you can say that the result is different from 0, right? Or you can reject the null. Okay. So when you're talking about a difference in means or a difference in proportions, this is outlined in the text, but I think it's worth reiterating. When you set up your null hypothesis, the null hypothesis is that there is no difference between the two groups. So women versus men equals 0, right? So like the mean for women versus the mean for men, whatever measure you're measuring, ACT score, persistence, numbers of hours doing housework, one minus the other equals 0. So they were saying that there is no difference between the two. For your alternative hypothesis, your HA or your H1, you could say men minus women is not equal to 0. Or you could say men minus women is less than 0 or greater than 0. This is to the point about something being one-tailed versus two-tailed. So that's actually pretty important in terms of setting up your questions and setting up your hypotheses. But basically, you're just testing whether the difference between two groups is 0 or not 0. And that's kind of the crux of all of this. Again, you just want to be sure that the difference that you're seeing between groups is not a fluke and that it's actually statistically significant rather than just something that is happening for a random reason or just for kind of like an environmental reason. I'm very intentionally not going through all of the formulas because they are all outlined in the text. But if you do have questions about how to calculate any of this, let me know. And I'm happy to talk through it or send a more detailed email out or anything like that. A couple more things. There's a whole section of this chapter that talks about dependent samples and doing analyses on dependent samples. That actually is a little bit more complicated than it looks. And they talk about matched pairs. You can talk in great depth in a whole other class about propensity score matching and other matching techniques if you're going to match students on characteristics and do analyses on them. That's way beyond the scope of anything we need to be talking about here. But this paired difference t-test and these paired differences is not really something that's used super often because you would, if you're going to do something along those lines, jump to this more sophisticated propensity score matching kind of framework. So if anybody for any reason is doing work that you think could benefit from some kind of matching, please be in touch. I'm happy to support you doing that. I have other resources that are beyond just this like introductory stats book that I think will be much more helpful. I actually use propensity score matching for part of my dissertation, so I don't like it, but I will talk to you about it all the time because it brings back bad memories. But no, there are much more sophisticated ways to do any kind of dependent sample work beyond what's in this book. Okay, and the last thing I want to say, there's a lot more unique, like complicated stuff toward the end of this chapter, which is great for your reference if you want to read it, whatever. But I don't think it's necessarily universal enough that you would be, go ahead and read it, but it's not really stuff that you'd be using day to day, especially in the work that you all do. I don't know that this would be coming up day to day. But anyway, as always, if you have questions, let me know. The last thing I wanted to mention, which is pretty important actually, is this idea of an effect size. So I have said this before, you have a result and it is statistically significant, so you shout it from the rooftops saying that my results are significant, we're going to change policy, we're going to change programs based on this statistically significant result of my analysis that I did. So something to think about an effect size, especially when you're thinking about the difference between two groups, is irrespective of whether something is statistically significant or statistically significantly different, what is the actual effect of, let's say, promise versus non-promise, or being a Pell recipient versus a non-Pell recipient, or something like that. To say that a different way is, it might be statistically significantly different, but is it really different, right? Is it like a distinction without a difference, statistically speaking? So the rule of thumb in terms of an effect size, and again, I won't talk through formulas or anything because they're all in the book, but if your effect size is 0.2 or smaller than 0.2, the effect size is considered pretty moot, right? So it might be statistically significantly different, but if your effect size is calculated to be 0.15, there's not a real difference between the two groups. So 0.2 is considered small, but a 0.5 is considered medium, and 0.8 is considered large. So if you ever do some kind of analysis that yields, or a program evaluation that yields a 0.8 effect size, that's huge. That's really, really amazing if you get that. So something to be thinking about as we talk about these differences between groups. And like I said, that's actually the rule of thumb for social sciences. If we were talking about medicine or public health, that's actually a little bit different. But 0.2, 0.5, and 0.8 are kind of the rules of thumb. And that's something that you should really sometimes have in your back pocket, especially if you're talking about a program like promise or sales or whatever. I already mentioned that there's some other stuff toward the back of the chapter that's a little bit more niche, unique. But if you have questions about anything, please let me know. And that is pretty much it. Those are the highlights of Chapter 7. So I hope everybody's having a great day and a great week, and I will talk to you soon.